Hello, my name is Edmund, and I am a volunteer for the Hyperledger community in Hong Kong. So first of all, thank you very much for spending the evening with us. So today we are very pleased to have Duncan coming all the way from the UK to share with us on a Hyperledger project called Hyperledger Sawtooth. So before we get started, so I just want to share a couple of housekeeping notes. So first, thank you to our venue sponsor, AWS. So Michael here is from AWS. So if any of you has any questions on how AWS work with other companies, what they're offering in terms of the blockchain space, please speak to Michael. Second, yes, as a community, we are always looking for volunteers. So if you are interested in helping the community, I would love to hear from you. So what we usually do is to be here a little bit early, like ordering food, making sure people are checking, and help to record the meetup, as well as to help to clean up. Pretty much that's it. And as a little gift, we do have quite a number of Hyperledger t-shirt here. So if you guys are interested, please do let me know. Yes, so next, so the slides and the recording will be available on meetup.com right after this event. So you probably don't need to take pictures and all this. Yeah, so next I want to pass it to Julian Golden, who is the head of Hyperledger Asia Pacific, to share with us more on the Hyperledger Hackfest.
First I'd like to say thank you to Edmund, right, for doing such a great job. 2 weeks ago, less than that, we pulled together this event so quickly, so thank you. So should we go to the next slide?
Sure.
So we have, I'm assuming everyone knows what a hackathon is, right? Well, every year we have something called a Hackfest, which is a similar name but different. It's where we get all the core developers come together. So we have developers in all these different projects developing technology, all sitting behind their machines in different parts of the world. And Brian always says it's great to get them all together in one place. We do that once a quarter. In APAC we do that once a year, and next quarter it's going to be in Hong Kong. So I'm looking at venues. We've got a couple of venues lined up, some pretty good venues. But the thing that we want to ask the community is, what is the date? Because we've got this thing called Chinese New Year, right? Right in the middle, right? So we have three options. We have the 14th of January, the 25th of February, and the 4th of March. And we have a doodle thing here for you to vote on. So I think they need to scan.
Yeah, so we welcome everyone who would like to participate and to open the camera or the QR code scanner. So I will leave this page here for a minute. You can all scan it, and you can all vote on the date which you prefer.
Okay, so that's it. Let's just have a great meetup. And also we've got stickers. All right, thanks.
Why don't you put the QR code on the meetup page?
Of course.
Yeah, we'll also do it. Yeah.
Actually, we put the URL.
Yeah, we'll do it.
I should have real.
I can copy this to the QR code website reader.
That's blockchain.
The blockchain.
Back and forth, back and forth.
Cool. So are we all done?
Yeah, we're good.
Cool. So next, I want to introduce our speaker, Duncan Johnson-Watt, who is the CEO and the co-founder of Blockchain Technology Partners, which is a corporate member of Hyperledger, and he is also a member of the Hyperledger Speaker Bureau, and he also organized the Hyperledger Scotland meetup. So I would like to next pass it to Duncan. So thank you.
Good evening. So, so this evening I wanted to talk about, give you an overview of Hyperledger Sawtooth, and also talk about how one should approach deploying and managing it. So, by way of background, I've been involved in automation and operations for many years. I'm a lapsed CTO, so take pity on me, please. But one of the things I used to do in the bad old days was I would develop software and then throw it over the wall to the ops. That was DevOps back in the 90s. So, and they had to either catch it or drop it, but mostly try to figure out what on earth it was we'd created. So we've moved on, I'm pleased to say, a lot since then. In fact, one of my co-founders and co-conspirators, Kevin, is working with me for the third time, and he was the guy who used to have to try and catch this stuff. So when I was CTO at Internet Fixed Income, doing ATS's alternative trading system back in the day, it was his job to try and make sense of whatever it was we thought was a suitable application for production. So, and you learn the hard way. If you ever, hands up who has actually either been involved in operations in a production environment where it's not necessarily life or death, but if it's financial services, it's certainly very expensive if things go wrong. Okay, few people with grey hair by the looks of it, prematurely grey. So anyway, I'm going to do a very short introduction to us as a company, what we're about. Blockchain Prime is, of course, none of you know what blockchain is. I'll quickly step through that, rest assured. This was part of a workshop that I did, or I contributed to, I should say, earlier this week. Then get into Sawtooth, where I'm going to lean very heavily on Dan Middleton's slides. In fact, they are his slides. They're the slides from Hyperledger Sawtooth 1.0. So he will be producing a 1.1 shortly. So as with all these things, it's fast moving, and so what I'm showing you is still current. And I'm pleased to say that 1.1 is not going to be so different that you've got to sort of re-engineer everything. But he will be producing another deck, and we're trying to persuade him to actually put it on the Hyperledger website, where I think it would be extremely useful. Then I'm going to talk about what we've been doing with Sawtooth and the B2B platform, and then I'm going to do a demo, which is a really bad idea, and some people very bravely have showed up the second time, having seen me attempt to do this demo, or in fact, I think you skipped it entirely. It was very wise, because there's a really nice Sawtooth demo called Tic-Tac-Toe, or Noughts and Crosses, and I was struggling to get that to work. So that was not a good experience, but I have now got it working, I'm pleased to say. So, having instilled immense confidence in all of you with those opening remarks, this is Kevin, looking suitably serious. He's really, what I'll be demoing today, a lot of the work is down to him, because when we started out on this journey with Blockchain Technology Partners, my initial thought was to use something called Apache Brooklyn, which I know and love, having helped create, and it's a top-level project within the Apache Software Foundation. It's really designed to, if you're not familiar with cloud formations, it's a kind of generalization of that idea that you can create blueprints. Those are essentially templates. Come in. And then use those to deploy and manage applications. But its strong suit is really dealing with, in many ways, legacy applications. And by that I mean anything that predates containerized platforms, orchestration of said containerized platforms, and the notion of services or microservices. So under Kevin's direction as Chief Strategy Officer, we've actually pivoted away from Brooklyn and are now focusing on Kubernetes. So we're learning as we go, and our thinking is that Kubernetes, not only is it mainstream, and by the way, there's now a Sawtooth-core Docker Kubernetes folder, where some people have contributed some manifests if you're interested in this stuff. And it's become the sort of de facto standard for orchestrating containers and orchestrating Docker in particular. In fact, it's so successful that Docker, the company, has given up on Docker Compose. Anybody that doesn't believe that is true. They still offer it, but it's gone. And what's important in our view is that it's also an open source project that was originally created by Google, but is now part of the Linux Foundation. So it's under the Cloud Native Computing Foundation umbrella. There are lots of umbrellas in the Linux Foundation. Foundations, greenhouses, umbrellas, overloading the term project. So if you said Hyperledger project, that's wrong, because Hyperledger is not a single project, it's a suite. And not only that, it's a suite of a suite of frameworks, one of which you probably have heard of called Fabric, and then a set of tools in varying degrees of maturity or immaturity. So Anyway, so our mission, when I'm not rambling on like this, how long do we have, by the way? Is it 9 hours? Okay, good, right. Our goal, simply put, is to really radically simplify the adoption and the use and the value of blockchain technologies, and particularly focus on enterprise, and hence the joining the Hyperledger community. In fact, digression, I'm a repeat offender. Cloudsoft, my previous company, joined in the first wave of non-founder or core members back in 2016. And when I started BTP, we again signed the pledge. But the idea is, bringing blockchain out of the science projects, out of the sort of labs, and making it something that's easy to consume, and more importantly, I hope most of you are developers, easy to work with, so that you can actually develop applications, because it's a piece of middleware. At the end of the day, middleware is just that. It's no use unless people actually work with it and develop applications that have real meaning and real value. And sometimes that means starting quite small. So not trying to boil the ocean, but just solving a point problem. So brief advert for another member of the community, Monax. So Monax contributed Hyperledger Burrow, which in the Sawtooth community we use. That gives us our Ethereum virtual machine. We'll talk about that a bit later. But they've now pivoted and are saying, we're going to go for an agreements network. So we're going to, Casey, who's speaking at various events over the next few months, their CEO is actually a lawyer by background. And so they've decided, let's create a useful blockchain-based application or service, namely a marketplace for legal agreements. So in the UK, if you don't write a will, the government gets everything, which should be some sort of incentive to actually write a will, but people are very lazy. And also, in the old days, you would go to a newsagent and buy a will from W.H. Smith's. So the idea is, go to a marketplace, get a document that's easy to understand, that's been curated, fill it in, forget about it. It will be looked after and managed throughout its life cycle. And a will is only ever invoked once, so it's a one-time fire and forget. But there are many other contracts which have a lifespan, be they insurance or be they anything that has workflow associated with it. So look out for Monax and their agreements network. It's a great example, I think, of starting with a very specific and very useful, valuable service. So what do we do? Well, it's all about permission, and that's why we're here to talk about Hyperledger. It's all about permission blockchain platforms. We're creating one built out of, as I've already said, Hyperledger Sawtooth and Kubernetes. I was talking to somebody early on about, I think you mentioned Hortonworks and Hadoop, and if you remember the sort of whole history of how Hadoop came about, it was really hard to wrestle to the ground. It was very complex. And then a couple of companies came along. Cloudera was one, and Hortonworks was another, and they actually created things within the open source community, things like Ambari that came along that gave you blueprints for Hadoop. And so basically made it manageable, made it tractable, made it useful, and then added other services on top. So this is basically the same idea. So there's nothing new in this. It's just the domain of discourse is really blockchain, and within blockchain at the moment, our focus is on Hyperledger Sawtooth. So we work with people to really use this platform, and as the third bullet point says, we're also very happy to collaborate with them to develop the operational model going forward. So we'll be talking a lot today and demoing running in the cloud, in particular AWS. That's, I think, a very good first base, but not everyone wants to stay in that world. Some people want to do a hybrid thing. So it's really making sure that you understand and work with your customer and develop the right operational model. So anyway, that's all about us. Co-creation, by the way, this is something we vehemently believe in. It's working together, and it sort of makes sense because I come from and have been involved in open source for a decade or more now. The notion of community and collaboration in open source is a given. And if anybody, and people still do this unfortunately, looks at an open source project and says, it's nearly but not quite what I want, so I'll go and write what I want. That's kind of, that's really not polite, because what you should do is say, well, where or how does it differ? and can I talk to the people who are working on it, and can we have a discussion about it, or maybe I'll contribute a pull request that says, how about we look at it this way, not that way? So co-creation is doing the same, but more on a business level. So it's saying, let's co-create a solution that, as it says here, delivers a mutually valued outcome. So a bit of MBA speak, I know, but there's a serious point here. So the primer, the slides are here for anybody that needs them. I pulled out some quotes from Gartner. I won't dwell on them, but it's interesting looking at the way analysts view us as a community and blockchain. They're not negative, but they are, I would say, pessimistic, which is always the way when you're somewhat early. So we're both early and late in a way, because blockchain as a concept has been around for forever. But in terms of its adoption, particularly by enterprise, we're still at a very early stage. But that means it's the right time to get involved. So now is the right time to start a company or get involved with this technology, because it's still nascent enough that you can make an impact, make a difference. But it will be a while before it becomes a mainstream technology. And so Gartner think that that's going to take sort of five or more years, and that there will be some spectacular disasters along the way. There have been a few already. There will be more, but there will be some successes. And so according to them, and I've looked at the data, and it's they're saying really get to the sort of mid-20s. That's a long time ago for me, but the mid-20s, that's in 2025, 26, and that's when it will really hit its stride and really grow from strength to strength. So we've got this real opportunity as a community to get stuck in now. So enough of that. I changed this slide. If you go to the Gartner slide, it said Hyperledger Fabric. This is a problem. This is a pain or bane of my life. Well, it's both actually. It's both a pain and the bane of my life. In that IBM, God bless them, have done such a brilliant job marketing Fabric that people think Hyperledger and Fabric are one and the same thing. They are not. And the only thing I'll say about Fabric is, if you're a consultant and you want a job for life, go with Fabric. If you want to work with a modular, sensibly architected platform, go with Sawtooth. It's your choice. A job for life means, by the way, you'll be maintaining this for the rest of your life. So be careful what you ask for. This is not being recorded. Oh, sugar. Serious point. I have raised this, as Julian knows, because I think as a community we do actually have to start addressing the question: why are there so many frameworks, 5 and counting? What do they address or not address? Because if we don't, people will make up their minds, our minds for them, if that makes sense. So I think we owe it to ourselves and to the community, and I would recommend that we do this at the Member Summit in a few weeks' time, to come up with at least a stake in the ground as to why we've got so many of these and what the point is. And to be fair, make comparisons. And also make comparisons when it comes to things like benchmarking, but do it in a way that is scientific and is reproducible, because there's a lot of benchmarks flying around at the moment which are frankly rubbish. So there was a Deloitte report that's been pulled, thankfully, because I complained and said this is absolute rubbish, or was that effect. But the reason it was rubbish was it was comparing apples and pears. It was running Sawtooth in dev mode. And if you read the small print, or even actually it's quite large, it's normal size print around dev mode, it says, do not use this for any benchmarking, do not use this in a distributed multi-region benchmarking exercise such as Deloitte. So that has gone, but it caused me personally real grief with one particular opportunity, because that's what they had. So I'm not going to stand here and do a startup and not fight back if we have to deal with that sort of stuff, because it's rot. It's rot and it's rubbish and it needs to be addressed. So I will be raising this at the Member Summit, which is where we can be quite open and honest with one another, right? Yes. That's the idea, yeah. And people might cry, but... So anyway, let's get serious. Let's talk about Sawtooth, and let's go to the man, Dan the man. So what I'm now going to do is walk through, and please, if you have any questions, jump in. These slides will be available along with the recording right afterwards. But Dan is the sort of, he's a member of the TSC. If you've not met him, you have to at some point. He's a real live wire, really passionate about this, knows his stuff, is still very much a hands-on sort of architect. So he is one of the lead maintainers of the core, and tremendous guy. So these slides are all credit to him, and any mistakes, any sort of confusion is all down to me, not Dan. Okay, so links there to the code and examples and so forth. And because these slides were prepared for the big announcement, which was a while ago now, it was like February, March timeframe. So time flies. But this was a coming out parade for Sawtooth. Very important that it reached 1.0. So what was the philosophy? And this is kind of important because having been involved in dealing with large-scale distributed systems, some of which were not designed to be large-scale or distributed, and some of which were, fortunately, the successful ones, that is. Some of the design principles here were, let's start out knowing this is going to scale and have to scale, right? So let's not think, it's time to do the scale feature. I'll just add scale, yeah. So product management, new feature, Jira, scale. Okay, that isn't going to work. It needs to be easy to use, and there's two aspects to that. And in some ways you could say deployment and development, or essentially, is it the operations that comes first, or is it the chicken or the egg, as we say? But development has to be easy, and not just easy, intuitive, and something that you're not constantly fighting because the mental model's wrong, okay? It also has to be easy to deploy, because if all you can do is develop something on your laptop and then say job done, you're kidding yourselves. And I'd almost be tempted to have a blanket ban on anybody running any, and not just Sawtooth, Fabric, anything purely on their laptop, unless they can run a decent sized Kubernetes cluster on it, in which case they're okay. But if all they're trying to do is spin up a few Docker engines Docker images in a Docker engine, that is frankly going to confuse you. It's going to give you misleading results about eventual execution. This is the antithesis of high frequency trading platforms where you've got to react in nanoseconds, because you have to understand that things will take sometimes minutes, and sometimes two things will try to do the same thing, and one will succeed and the other will fail. And in that sense, you have to understand not just the CAP theorem, which is dealing with sort of consistency, availability, and performance, but it's doing that and it's blockchain. So there's even more kind of nuances around that. So having a blockchain that's tunable to an application or set of applications is also very important, and that's one of the things that Sawtooth provides. So you can set things like the number of batches in a transaction, the mean time between transactions, et cetera, et cetera. There's no limit on the size of a block, but clearly you want to be sensible about how you treat these things. This is Dan is brilliant. He would give you like 30 minutes on remaining distributed. Distributed ledgers need to be distributed. I'll just say one word: orderer, and leave it at that. Some of the features which are now, I would say they were new, but now they're sort of commonplace, and they are incredibly useful and powerful, were listed here. There is, how can I say it? There's, I'm not sure which order to deal with this first. I'm going to talk in a minute about transaction processes and transaction families, but let me sort of preface that by saying, imagine you can partition the world. Now, we all know what partitioning means in the sense of a database, or you can partition the world of Sawtooth in much the same way. You're not saying, I'm only going to look after a piece of the radix Merkle tree, or a piece of the global state, the global state, or a piece of the block store. No, every node, every validator is going to have a complete copy. But what I can do within that tree is actually partition off the TP for settings, the transition process for settings, from one for tic-tac-toe, from whatever, identity, etc. What that really means is, in terms of the way things are operating on the network level, is you're basically ensuring that payload can be routed based on just 3 bytes. Okay. So the other thing, and I'll come on to it, in more detail is the clear separation between the network, which is essentially dumb. It just does what it does extremely well, but it has no idea what these transactions mean or what these transaction families are. Think of a transaction family as just an app, a distributed app or a process, a business process, I should say. But that allows for not quite parallel in the sense of truly parallel, but of optimized scheduling. So it's possible, therefore, to determine at the level of the validator, which is dealing purely with network and is running on 0MQ as a substrate, another good choice because it's a message bus that everyone knows and understands, is that you can make intelligent decisions and you can be provided with hints by the actual transaction processes themselves as to what is related to what. And that gives you the ability to optimize without actually destroying the integrity of the system. So you've got that kind of partitioning. So you can think of that as partitioning based on domain of discourse. Then you've also got the ability to partition based on where that execution is taking place. So it's not the case that everything has to execute on every, or every validator node in the network has to have a copy of every transaction process. So in other words, process messages for every family. That, in fact, is something you probably don't want to do. And the more you get into organizations and multiple organizations and things like consortia and so on, there may be stuff that you only want to run in a subset. So now we're doing Venn diagrams as well as partitioning. Those two, used wisely, are incredibly powerful. Simple, I would say, core, concrete concepts, but used wisely give you a huge amount of flexibility and freedom. And appeals to me as an ex-mathematician, because it's a nice way of sort of blocking and tackling and thinking of how to divide up the world. So anyway, that's that point. On-chain governance is interesting because what that means is that you'll see there's a settings transaction processor. Everything that's done is recorded on the chain, so every configuration change, adding another validator or whatever, it's all there, it's all auditable at the end of the day. Proof of elapsed time, anybody know what that is? So imagine you're all asleep by now. Okay, you are all asleep by now. And then at some random point, one of you will wake up first. Right, and it's now your job to handle the next block. And the idea of proof of elapsed time is that essentially that is a fair mechanism for determining where processing takes place. Now, it only works in a permissioned environment, and it can work independent of SGX, which is the Intel security enclave. So it's not dependent on hardware, although there is a version that can use that hardware. But the idea is that within the Sawtooth core itself, it's checking to make sure that there is no bias, so that there is a sensible distribution of who wakes up. So it's not like Michael Edge has sneakily changed things, so he gets woken up and does more work and is doing all kinds of crazy stuff. Not he would, of course, but. And then I'm not picking on you, am I? Sorry. And thank you, by the way, for hosting this. Much appreciated. Probably never do it again, but never mind. So Seth, right, is the Sawtooth Ethereum integration, Seth for short. Really powerful. Still a work in progress, but the idea here is you can take, if you've been used to working in the Ethereum world using Truffle and Remix and Solidity and Zeppelin and things like that, all of which I've learned to say with a straight face, like Truffle especially. That's just, it kills me every time I say that. But no, these are tools that are now de facto standard tools for developing smart contracts in that world. So the Seth integration gives you the ability to do that on a Sawtooth network. And there is some experimentation going on in the Fabric world to try and provide the same basic idea. But what you get in Sawtooth is you actually get the Burrow EVM integrated as a transaction process, and I'll show you a picture of that in a few minutes, if I ever get off this introductory slide. So, basic concept. This is all you really need to know. There are clients. They're important because they actually interact with things. There are transaction processes. They do something in response. So, and depending on, again, the domain of discourse, messages will be routed to them via the validator, which also provides what they call mediated access to the state. So that state is really the global state and, in essence, the story of how we got to that state. So are you familiar with this concept? It took me a while to get my head around it. When people say Merkle trees, everyone's eyes glaze over. All a Merkle tree is an efficient way of storing data, so it can't be corrupted. It's also a very efficient way of finding a way to a particular part of that tree, and that allows you to then query and get state back. The state is being manipulated independently of the blockchain, let's be clear. But the blockchain, or the block, they call it block store, but it's the chain, records every change from the beginning of time on that tree. So you've got to have that clear in your head. It took me a while to figure this out. So, you know, I was looking at this going, huh, that doesn't look like that's a tree, not a chain. No, they're two completely separate things. So if you take away nothing else from tonight, it's just global state, one thing. The story so far is really the blockchain itself, which will describe every change made and how that change came about. So that's really important. That's kind of, I think, one of the aha moments for me, certainly when I was trying to get my head around this stuff. And conflating the two just causes you get a migraine very quickly. So fleshing this out, as you'd expect from this pattern, all that really happens that sort of makes life easier is that there is a REST API that sits in front. And so the standard sort of comms is protobus if you're familiar with that. And there are other validators out there somewhere, and the whole thing is kind of networked. But there's a little bit more to it than that, obviously. So there's, as I mentioned before, and this actually makes it very clear, right? There's the block management, which includes the block store, and then there's the state. And this is where, if I have not made it clear before, you can see the separation between what's happening at the network layer, which is all about routing opaque messages round, and what the client is asking for and what the transaction processor is doing in response to those requests. Okay, really simple, really clear, and works a treat. So then finally, I won't dwell on this. You can study this at your leisure, but there is this notion of parallel or optimized scheduling. I'd prefer if it was called optimized or intelligent scheduling that's going on that allows you to sort of avoid bottlenecks as far as possible. And what each of these transaction processes represents is essentially a distributed application, or rather instances of the transaction process dotted around the network provide you with that distributed application. Okay, and the clients can come in from anywhere. Again, if you're testing, make sure clients come in from anywhere. So when I get around to doing the demo, you'll see us using a load balancer, in this case an ELB, in front of the REST services for each of the validators to distribute load when we're firing requests in to test stuff. And again, it's 101 QA. Don't just sit there and fire things at one validator in a network of 100 or whatever, because that's not the way it's going to work, unless you have one client, because you've written a really rubbish application and there's one person in the world using it, in which case it is a fair way of modeling that. But anyway, same as Fabric, there's a high degree of choice of language that you can use for both the client and the transaction processor. And that, again, is because there is this very clear separation between the network, which you really don't need to know what it's implemented in. At the moment it's Python, but there's a lot of reworking going on because, as you would expect, as this thing has been worked on by more people, there's been a sort of a certain amount of refactoring, which I'll mention again in a second, but also reworking of some of the core components. But if you're thinking of this from a developer point of view, there's no mandate. As long as you follow the guidelines for developing the transaction family specification, and then developing the transaction processor to understand that set of messages, then you knock yourself out. And then finally, Seth, and as I've said before, there you go. It's a transaction processor with a difference in that it also provides this, and this is what people expect in the world of Ethereum. There's an RPC mechanism that means it will understand and will happily talk to you, or you can talk to it, I should say, through your favorite tool. So from a CI/CD point of view, you can carry on as before. There are a couple of, not so much gotchas, but there are things that there's no gas, okay, and some of the detail, and I said I was a lapsed CTO, so just accept as on principle. There are some things that have to be provided in the way of services that don't quite map. So block info is one of those. But the guys are working on and there's a good core set of maintainers working on making sure that that doesn't violate the compatibility, okay? But at the end of the day, that I think is it's not a one-off science project by somebody trying to hack it. It's actually a part of the Sawtooth family, and it's a good example of reusing stuff from another Hyperledger project, in this case Burrow from Monax. So, on-chain governance, configuration stored. If it changes, the change is stored. All of this you can actually see when you first start up a Sawtooth network. There's an awful lot of activity, and blocks are created, and all sorts of other good stuff. And you're going, but I didn't do anything. No, you didn't. Well, yes, you did. You started Sawtooth network, and so it came up. It sorted itself out. One of the validators said, "Hey, it's my job to create the Genesis block, etc., etc." And then finally, I think we're close to final. Yeah. The notion of pluggable consensus protocols, really, really important. And do not try this at home, but it is in theory possible to change the consensus protocol on the fly. I'm not sure there's a good use case for that that leaps out at me, but the point is it's configurable like everything else. And so joking aside, there might be a rationale for at least updating a protocol, etc. But that's really a heavy-duty discussion, and that's really down in the weeds of how do we operate this thing over not hours, minutes, days, but months, years, decades. Don't forget. So there are a number of it says future consensus options. They're actually already available if you're working with the sort of the master. If you're ahead in the Sawtooth project, because they're already available for you to experiment with. 1.1 is due out imminently, I will say. So, with me so far? It's great, isn't it? I mean, and so much easier to understand than pretty much any other framework. So, a little bit on application development. So I'll be coming back with Kevin and others to help and actually give you guys the real story. But we're probably going to do a workshop where we're going to split it into operations and development, application development, that is. We think it's easy enough to understand that people should have a good grasp of the operations in terms of how to deploy at least a fairly standard single Kubernetes cluster config, but then really split it into more detail on the ops for people that want that, more detail on really the application development and how to approach that for people that want that. Not because we're trying to split things in the middle, but I think everyone needs an appreciation of the other. But if your day job is developing apps, then it's probably a good idea to spend more time on that, I would hazard. So as I sort of said before, there's clients initiate. I mean, who's done object-oriented programming? Who understands methods and messages are really the same? Invoking a method is sending a message. Yeah, makes sense? So this is all this is really. So you're essentially, there are a set of publicly defined method calls, which are really messages in this world, or transactions that come in, inbound, validator will route them to, probably by default, but not always, to a transaction processor local, if it has one that is in the right family. If that's overloaded, it might actually fan out work across the network. And bear in mind, this is back to what I was saying earlier, these messages are coming in from clients notionally or potentially attached to every validator. So it makes sense where you can to process at least that initial transaction locally. That doesn't mean you're suddenly not a distributed application, it just means you're optimizing performance. But the idea is that as allied with that is, and this is the critical thing and the hardest thing to get right, is the data model itself. So what do all these method calls, all these messages, all these transactions do to affect or change the state? And I'll give you the example in tic-tac-toe, where obviously one of the methods or one of the messages or transactions, they're all the same thing, is create a new game. And so the transaction processor says, all right, happy to do that, so long as various things are true. It's a game with a new name, so I'm not trying to create the same game twice. And the person or the identity of the user, the assertion is that Jack or Jill, in the example we'll look at, exists and has the credentials to actually create a game, and so on and so on. And then it will do things like make sure that Jack doesn't do 2 moves, because if you do 2 moves playing noughts and crosses, you're going to win. 2 in a row, I mean, not 2, but so it's a nice example because it's something which I think is has been played for centuries under different names, and so it gives you a good way of understanding how to build a transaction process, the transactions in the family. And I also believe, by the way, it's how we all learn. We take something apart and then hopefully put it back together. I did this badly when I was a kid. We were a 1-car family, and I thought I would fine-tune my dad's car. So with a couple of mates, we took the engine out, we took the bits, thought that was interesting, to do that, had no idea what we're doing. We better put it back together again. We did, and the miles per gallon went through the floor. The performance was rubbish because as we did, we found there were a few bits that hadn't gone back in. But on the other hand, if you do it well, then you will learn by unpacking something somebody else has written, and that's a good way of along with obviously the guides and so on, although I am a firm believer that most manuals only make sense once you understand the thing itself. So there are great people that can write documentation, but it's so hard to do, to get it to the point where somebody can actually learn through that process rather than saying, oh, now I understand how it works, because I figured out another way, now I read the manual and it all makes sense. So anyway, so I've kind of said this. The twiddles, I would say, saying twiddles smart contracts immediately puts you into this sort of whole what's a smart contract debate. And I think, what is a smart contract as far as I'm concerned is something that runs on Ethereum. Okay, so as far as I'm concerned, that is the definition. But these are, quote, or twiddles, smart contracts. What they really are is bits of business logic, hopefully fairly complete, so that there aren't things you forgot about, edge cases that you haven't sort of accounted for. But at the end of the day, that's just about creating a sensible, well thought through application where you understand every possible event, message, invocation, and you understand how to manage state, and you'll never get into a sort of a live lock, which is the more likely of the 2 scenarios, as opposed to a deadlock. What do you like about this picture? Try and make it interactive. Engineer's induction, right? Engineers mostly can only carry around 3 things in their head at one time. So if you ever heard of engineer's induction, by the time you get to 3, that is your inductive proof. It's true for n equals 0, 1, 2. It must be true for n. The point is, back to the point I made earlier about the validator and the network being incredibly simple, but just good at what it does. All you can do as a transaction processor is say, hi, I'm here, and provided you are accepted, allowed to be running on that validator, then you're connected. And then all you're actually going to do is then be asked to process the transaction, so apply. And then all you can do in return is get or set some value somewhere in that tree. Okay. You then, this obviously is the key in terms of have you thought of everything? Have you as I said before, accounted for every edge case? But in principle, that's all you need to know is the interaction with the network, the underlying network is extremely straightforward, and it should be. And then it's the devil's in the detail in terms of what apply then actually does. But all of that is only in the context of the transaction processor and the state it is managing, the tic-tac-toe game, its state, etc. So skip that. Skip that. I want to do a demo. I don't really want to do a demo, but I feel I should. There are some good examples. In fact, two are called out here. There's a third one that's been worked through in some detail now. But if you go to Sawtooth, Hyperledger org examples, I think you'll find all three. They're good because they're quite fully worked through and fully thought through. And Edmund, I mean, you might say something about supply chain. I know you've done a meetup on it, I think.
No, I just run. I get the supply chain example running. So for those who are interested, I'm happy to share.
So we're really interested in what Edmund did, and in the spirit of co-creation, aka I don't have to do the work. Sorry, did I actually say that? We would like Edmund to try and get the supply chain example to work on a instance of the Sawtooth network, which we're going to create, or he will create. And the reason that's important is because it's a good test of have we done everything right, is to give somebody else the keys to the kingdom and see if they can actually specify, essentially add that transaction processor to the mix and the manifest and so on and so forth. So looking forward to doing that. So as Dan would say, check it out. Check it out. Get involved. Whether that's improving the documentation, definitely would be helpful, whether it's testing it, whether it's getting to the guts of it, it's all there. So Dan says, thanks for listening. I'm sure he would if he was here. So next slide. Let's talk about taking a lot of this and making it, if you like, tractable, reusable, repeatable by mere mortals like myself. I'm the idiot that makes sure everything we do is idiot-proof. That's what it means. It means somebody in the company who will invariably break things through no fault of their own, just because they will stumble into things because they're not the engineer that wrote it that knows, no, never do that, because they'll just guarantee to do that. So the idea behind the platform is to make it something which is robust enough that I can use it, that provides you with a distribution. So old-fashioned words, but the notion of a distribution is exactly the same as it was with Hadoop, or is with Linux through Red Hat. Here is something which is signed, sealed, and delivered, will work. We've built the Docker images that are pulled down. They're pulled down from a well-known Docker Hub organization, et cetera, et cetera, et cetera. And if you're a big enough and bad enough enterprise, you want all that on-prem, yes, we can give it to you. But in reality, aren't you better off at least starting and looking at this stuff and working with it in the cloud, because it all just works. And then the other thing is, besides that, is a unified user experience. And what do I mean by that? You'll see me, by the way, what I'm going to demo is what we're not ever recommending anybody ever does in production, because it's fraught with risk. Why? Because it's me at a keyboard. But I'm going to do that to unpack, same as I was saying earlier, unpack what is going on behind the scenes, so you get a real, I hope, sort of granular, sort of tactile feel for it. But the idea is, as part of that, you have a unified experience, both in terms of specifying how you want your network to look. If you want a rough approximation to what it might look like, look at the Cledo example, which is actually running in the AWS marketplace. So Cledo is a consensus company, and so they focus on standing up Ethereum, or configuring, I should say, they're not standing it up, they're configuring, I think, if I'm right. But what's nice about it is they give you a very simple, step-by-step way of rolling out an environment that you're happy with. And so we have the same goal, and it's all about that, radically simplifying the enterprise adoption of this technology, and that's the only way we can do it. There will be the usual starter, professional, and enterprise, which means the price goes up and as you go along, but it means also that you get more in the way of an SLA around management and operations and support. But crucially, you can start with a credit card and an Amazon account, or Alibaba or Azure. We're going to support them all eventually. And so you can start small, pay as you go, ask us questions on Slack or whatever. Probably WeChat here, I guess, as I've discovered when I created a Slack channel, and everyone Why did you do that, Duncan? It's so easy. Just do we? Oh, okay. Right. The marketplace is I'm a huge fan of this. I was quite involved with this CloudSoft with, in particular with Dave McCann, who's the VP for AWS Marketplace and the Service Catalog. So CloudSoft was more involved, I would say, on the Service Catalog side, which is really take some slice of the marketplace and curate it for enterprise and integrate with things like ServiceNow and so on. So you get the whole ITSM experience, because large companies still want IT service management over and above. But what they've achieved in a few short years is they've made the marketplace, the concept, but also the reality, the default channel for distributing software. So you don't download it, you run it, you spin it up. And even Oracle's had to kind of agree to this, which it took them a while to do. But the idea is you go to the marketplace, and whether it's a simple AMI, you spin up an instance and you're done, or whether in our case, you spin up an instance, and that's kind of, if you like, the seed that will then allow you to then deploy various networks, or whether it's a SaaS offering. It's all there, and now it's got to the point where it's integrated, so as a third party, like ourselves, you can also do integrated billing through it. So that means that from a customer point of view, it's frictionless. And from a provider of a service, it's also frictionless. So that's kind of a win-win. But anyway, it'll be there. So I better sort of show you what it is, I suppose. This is really hard to understand, right? So that's how difficult blockchain really, really is. Okay, so I realize I'm going to have to explain this in tremendous detail. There are things that process things, and they do normal things like business process, workflows, and that carries on just as it always has done in a lot of cases. And by the way, Change Healthcare, which is a Hyperledger partner, member, whatever, have used exactly this pattern in real life in insurance. So rather than disrupt everything, say, oh, throw everything away, we've got to start from scratch, which is nonsensical. They said, no, let's use blockchain for what it's been designed for, which is to record critical data in an immutable fashion, in a non-repudiatable, what a word, fashion. And that means that there is the ability to collaborate, even when, whether it's through it's by accident or design, errors creep in. So this is a good example. And then there are ways of downstream taking information out of the chain. So rather than querying the chain, which is actually quite hard to do, hard in the sense of tedious, there's nothing wrong with actually doing what in Sawtooth terms is called a ledger sync, which ledger sync, SYNC, does exactly that. It just syncs the ledger to a standard NoSQL database or whatever of your choice, where you can sort of pour over the contents to the extent you're allowed to, obviously, but never ever view that as a single source of truth. It's not. The truth is still here, but it's all about simplifying, again, make it easier to, in this case, the regulator might be Chinese government, wanting to make sure that data centers really are performing to the PUE that they've been told they have to perform at 1.3, but are not fudging that data. Not that any data center hosting provider would ever do that, but in the rare, just to eliminate that potential, you can do it on the blockchain. Simple example. So you can go from simple to much more complex. So, all right, demo. So, what can I say? The good news is we're using standard tools. That's very good news. So we're not saying, welcome to our world now, here's a whole bunch of new stuff you've got to get your head around. Oh, and as I said earlier, you won't actually probably, most of you need to know what COPS and Kube Control, or Kube CTL, or however you pronounce it, really is about. But they are standard, they're standard tools, and that's important. So in the case of COPS, hands up who's heard of COPS? Okay, good. All right. Okay, this is a really hard question. There's a T-shirt or a sticker. If somebody gets this right, sticker.
A t-shirt.
T-shirt. we'll take one off somebody who's got one and give it to. What do you think COPS stands for?
Kubernetes operations.
Yes.
I already have a T-shirt.
Okay, so that's self-preservation. That's you outsmarted. It's extraordinary because when I first looked at it, I thought that's interesting, but when I looked at it again, I thought, wow, that's really interesting. And when Kevin said, hey, we're using it, I'm going, wow, that's extremely interesting. And then I looked at the rate of progress and the number of contributors, and we're on 1.9.2, which was released at the end of July 24th. That's out of date, quote unquote, because 1.10.0 came out 10 or 11, maybe 12 days ago, and I'm sure there's another one out probably by now. And there are like hundreds of people contributing to this. So, people really, what are they saying? What are they telling us? Kubernetes has reached the point, critical tipping point, where it has to be managed. And so the best way of doing that, create a utility for exactly that. So this is about spinning up Kubernetes. This has got nothing to do with anything really, to do with blockchain or whatever. And then kube control, or kubectl, is the way you interact with said cluster. So without further ado, I have to do some work. And this is where the wheels generally come off, by the way. So I've got two windows here. Okay, so got past the first. So I'm now in the cloud. See? So what did I just do? I guess, what did I just do? If I skip that, refresh that, I'm out to log in. No. Okay, so there is a anonymous machine here whose key name is system. So this is basically the mothership. I know that because I deleted it. And I got Kevin saying, WTF, Amazon doesn't normally do that, what's happened? And I thought, so I just sit quietly and say, I don't know, Amazon doesn't normally do that, or shall I confess? I confess, because Amazon definitely doesn't go around killing things. But it now has a guard so that it can't be deleted by the idiot that makes things idiot-proof. But the reason I'm using that is that I have an account on that. Also, I think Kevin has given me an account so he can actually keep track of what I'm doing, and I can't do too much damage. And as you can see, he's running a Kubernetes cluster himself. So Amazon needs some money, so we always leave something running, so there's a collection bowl as you leave. So, oops, and look at this. I talk too much. So it logged me out. So I better move through the gears. Wait a second. Oh, do you know why? All right, what did I just do?
Exit.
I used exit, and then I looked surprised that it exited. I was trying to pull up export from my history, but I was being lazy. So I could have been doing this for the next hour. That's better. Okay. So what is this doing? Well, it's quite simple. Can you see that? Or should I try and make it a bit bigger? All it's saying, and this is a kind of a, oops, this is a COPS feature. Is it saying this is where we're going to store the state? So COPS needs to know somewhere where it stores information about the clusters that it's managing, and so we've got a little bit of S3 where we're going to store state. So if I go back to the presentation, what I'm going to do is, and this is closed source, which is, given I talked a lot about open source, kind of bad, really. But don't worry, it's not going to be a closed source for long. We're going to open source this as part of our roadshow. starting next month with the Members Summit, Hyperledger Members Summit. But basically, there's not a huge amount of stuff here. There's just some definitions of sort of boilerplate definitions of Kubernetes clusters. But this will run with things like AKS or any other sort of cloud Kubernetes cluster, as long as it exposes standard Kubernetes interface, which most of them do nowadays. But what we're going to do is we're going to go there and we're going to create, or in effect load a definition of my cluster. And we're going to do a little bit of magic, and in the interest of time, can somebody lock the door to stop people leaving? It's the wrong way around, because it was locked so we couldn't get in. There needs to be a switch. Right, so I did a whole bunch of stuff in one go. If I'd just stopped at the create actually just creates the definition or uploads the definition. It then adds my key to that, so we're controlling access to this. And then update is a very powerful COPS update cluster, name of cluster, -- yes actually does it. If you don't do -- yes, it just does a dry run and tells you what it's going to do. But in this case, there is no cluster, or there was no cluster, so update meant not just incrementally change it to conform to the definition, because you can edit the definition once it's stored, but actually said, wow, I'm miles from having this cluster. There's no master, there's no nodes, so I better bring up the whole thing, which is what it's now doing. So if I refresh here, and all is going well, yeah, it's spun up a bunch of machines, which are now my machines for my cluster. So none of this is hard, but our idea is just to make it even easier. And so that's happening in the background. It takes a few minutes, so I'm going to quickly walk you through what we're actually going to do once this cluster is here. So if I just quickly go here. Yeah, so validation failed. It just means it's still coming up. It even tells you, please wait about 5 to 10 minutes. Luckily, it's more like 4 here, but while it's doing that, let me quickly flip back. So far, this is just boilerplate stuff. What we're now going to do is deploy a Sawtooth cluster, and then what does that mean? You can, again, we'll make this available really shortly, but we have definitions, service definitions in Kubernetes speak for a number of core building blocks. And where it says type equals load balance, that's because we're using AWS will equate to an ELB, elastic load balancer. And the reason for that is because it's going to provide a load balanced access to those individual REST servers, which is useful for the kind of testing we want to do. It has Grafana, which needs to be able to see and talk to. So Grafana is just, you'll see in a second, it's just a way of visualizing what's going on. It's just basically, all it's looking at is InfluxDB, which is a sort of holding a whole bunch of metrics. Those metrics are everything from low-level stuff through to the actual state of the world, number of transactions, number of blocks created, that kind of thing, any backlog, that sort of thing. And then those then feed into 3 stateful sets. So we're going to have instance 1 of monitoring, because we only want 1 monitoring. We're going to have 1 next. Next is its next directory. It's a sort of on-chain identity service, RBAC. Really, it's RBAC. And then validated, and we're going to have N of those. And then when you unpack that further, stateful set, all of these components should be familiar to anybody that's sort of even glanced at the ops or admin guide for Sawtooth. But essentially, there's the rethink DB, there's RBAC ledger sync, and the UI, which I'm not going to try and demonstrate today. Monitoring, same story, and the one that's most interesting, and actually this is out of date because this shows you the number of components. If you remember, the Sawtooth set was a couple of components. So it's the TP and it's the RPC. Block info, identity, small bank, TP, blah, 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 and XO, tic-tac-toe, which is not on there. So now I'm going to see how that cluster is getting on. Any questions while I wait? I should have done this earlier. Here's one I made earlier, but there's actually a useful command. Sorry, cops. So this is a little bit more helpful because it doesn't just flash by. You can see that.
We don't see your terminal window.
Oh. Oh, sorry. You know why? Have you seen it at all?
Yes.
Yes.
During presentation.
Yeah. It's because Microsoft. Because Microsoft. Right. So yeah. So, ta-da! See, it was Microsoft that was holding up. Eli. Right. So basically, what it's saying now is that the cluster is up and running. All the machines were deployed. That was the easy bit, but it's now set up Kubernetes, which is good. So Control C out of that. And now if I quickly flip back to here, I won't put it into slide mode. That was a mistake. I'm now going to prove there is no man behind the curtain, if you're familiar with that expression. What that means is I've just run a kube CTL command, so show me what's there. And the only service it's running is at this point Kubernetes itself. So I've now moved from the cluster definition to a manifest definition. And if you look in here, and again, this is boilerplate Kubernetes. There is one that I'm going to invoke, which has been made for me, which is the Sawtooth demo definition. So this is a definition of Sawtooth that's designed for this demo. That means a couple of things. It means that it's running in dev mode, and it's designed just to run pretty much a very low transaction volume demo, which, trust me, the rate at which I type will be very slow. So I just come back to here, and this will be quicker than. So we're going from having no Sawtooth network, he said optimistically, to having a Sawtooth network. And what you can see here is it's set up to say 3 validators. So validator 0, 1, and 2. So desired current on one each of monitoring and the Sawtooth next. And if you look up here, you can see each of those pods starting. So when we say desired state 3 instances of the validator, we mean there are 3 pods, one on each on a different machine, not one on each machine, each on a different machine, which are being brought up, and there are 10 components. So the transaction processors, they're all Docker images being spun up at this point. The other stuff that's useful is the external IPs. These are for the load balancers, so for Grafana and for the REST API. What those will do is, and I'll just wait for it to come up, is let us look at the underlying state of the Sawtooth environment, and also through this load balancer talk to an arbitrary REST API client, API service, REST API service. So essentially mimicking requests coming in from different points context. So this will probably take another minute and a half, and I can't do very much until it's done that. I can do a little bit of preparation work. I can grab that. because monitoring is up and running, I can actually go and connect through to that. So this is not anything we've added. This is, again, what ships with the Sawtooth. And anybody want to guess what the user and the password are? Mm-hmm. Don't tell anybody.
Don't repeat that.
I don't think I can repeat that URL though, so.
Yep. And this always says, do you want to? No, I don't. No, I don't. Not now. Go away. And it builds up a picture of the world. And in fact, if I scroll down, the further you scroll down, the more detailed the data gets until you're down into the sort of weeds of, you know, real low-level IOs, disk, blah, 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 blah. So messages sent, etc., etc. And it'll start to get interesting as new validators come on stream. So if I quickly flip back to here, okay, we've got error image pool. Now this is interesting. This has happened to me once before. Once, I promise. It will be interesting to see what it recovers. Kevin assures me if left to its own devices, Kubernetes will recover this in time. I'm actually going to screenshot that. Okay, so 2 out of 3 validators have come up. This looks fairly benign. Any ideas why? If you look at the count, the others have got 10 out of 10, this has got 5 out of 10. What it's saying, I think, is I'm going out to the Docker hub, and we're going to the public Docker hub, and I'm trying to pull down a particular Docker image, and it's failed partway through that. So it's trying to start up a component, and it's failed. So it's done a couple of restarts. It's now got to 7. So it's a bit lumpy. But again, the good thing about Kubernetes is it's sorted it out. If you notice, it's now running. So these are the kinds of things that are designed to strike terror into the heart of the demo guy, but are actually quite good because, in a sense, it's what's good about the Kubernetes style is, you know, these things are designed not to fail permanently, but designed to be able to recover gracefully from failure. So if that's true, and all is well, then yes. So now we can see all of the validators that come up, and so we'll start recording data. So let me quickly switch to doing tic-tac-toe. So we won't explore the network anymore. I've done that. So tic-tac-toe, as I said before, it's a good, I think a very good example to work on and work from, because you kind of know what it should do. So there's nothing to explain there, but it allows you to unpack how this thing works. So the fun thing is you've got to actually run another neat feature, which is run a Sawtooth shell. What's that going to do? Not a huge amount, but it's very helpful. In that it's now basically it's spun up a container. It's a transient container, so it will lose state. So it's there just for you to experiment with. It's not something you necessarily would run in production. But what it's going to allow me to do, if you can see down here, is I'm now provided to do one more step. I'm now going to be able to actually sort of use the XO client to talk through to the validator network, to the Sawtooth network, and get the XO transaction processor to respond, hopefully. We're nearly there. The beers are just moments away. So I need this guy. And I need this because, as I think Michael pointed out, it's quite a lot to remember and type. And all this is doing is saying export URL equals dash dash URL HTTP colon 80 close quotes. What are the chances of me getting that right? Good. No. What's wrong with that? Ah. Oh man. That's. Let me try again. Is that better? Yeah. Okay. So the reason that's helpful is I can do list $URL. How many games are there? Well, there are no games. Okay. So back to here. This is my cheat sheet. I'm going to create. I'm not going to explain this, but except it's kind of obvious, right? It's going to create a couple of IDs for me. And it's doing it to save me, again, getting tied up in knots. Okay, so now I have Jack and Jill. So that was my housekeeping. Now, this is where I start praying. Not really that religious, except when I'm doing demos. Game one. Okay, so it's going to be Jack who's going to create it. And then I'm going to list the games after I've done that. Can you see that? This is as good as it gets when you're demoing middleware. Actually, no, it doesn't. Tell a lie. There's show URL game 1. Wow. This is like state of the art. You guys, I bet you couldn't write a program that did that because it's so hard to be that simple. But this is the Noughts and Crosses game. So now we're going to play the game, and we're going to make it interactive because I only know 2 moves, and then it's over to you guys. So I'm. This is a bit sexist, but Jack is going to go first. We flipped a coin. He won.
Consensus.
Okay, so, and I'll just put the, so, these are labeled 1, 2, 3, 4, 6, 7, 8, 9, which I noticed, by the way, was wrong here because when I got confused when I went to a cache point because it's the other way around. You probably don't realize it's the other way around, but it is, trust me. Anyway, so we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is then, what's a sensible move for Jill?
1.
1. You weren't by any chance looking at my...
Oh, no.
You're quite right. And again, just for the hell of it. Okay, so what should Jack do? And you notice, by the way, it's telling me it's Jack. And they've got you, these are the IDs. Or state. So if player 1, if Jill tries to be player 1, it will be rejected. But what should Jack do now?
4.
Okay. All right. Okay.
Out of curiosity, what happens if you try to take a place that's already been taken?
Meaning,
Right, so if I try to go 4, if Jill tries to go to 4, how will the server respond?
should we ask? Should we see what happens?
Sorry, I like to break things.
Yeah. Well, I think actually this is. I'm very happy to try that. So you want Jill? So you want the legitimate player to go,
Yeah.
but you want her to try and.
Go somewhere that's already
Yeah.
been taken by Jack.
Okay.
Oh, we'll overwrite the value of the
I don't. Well, let's hope not. No. Surely you could tell this said no way. You just got yeah.
It's just a bit too far. Sorry.
Yeah. So I mean, this is one of the joys of working with this stuff is you know, you really do actually have to spend a bit of time putting a sort of a more friendly UI in front of it, one which would translate that and actually, you know, so the client would actually be a nice graphical thing and would explain what that means. But yeah, it's the transaction. So you got the clients, because each one of these is a asynchronous invocation, so they could come from wherever. You've got the transaction processor, and its job is to maintain the state of the game. So it's the one that's deciding whether or not you can you know, create the same game twice by mistake, or you know, mix up the order, or in this case. So so Jill shouldn't do that. What should she do?
6.
Yep. Okay. Looking good. And so on. Should we carry on?
Does anything happen if you win or lose? Like, does the system
Plays a tune or something?
I don't know.
No, it will tell you the state. So the state will be tie if it's tie, or win-lose. So yeah, so it and it knows when there's nothing else to do when it's when that game's in the final state. Yeah, so you know, we can carry on. So engineer's induction means I'm happy now. It must work. But no, I mean we can carry on. So Jack, I guess is going to go for 7, maybe. Or is he going to be a spoiler and go for 3? 3. So this is really mean. Okay, so at this point, Jill's come obligated to go for 7. And again, if somebody tries to take you know, turn out of turn, make a move out of turn, then it will. So we're getting pretty close to a draw now, aren't we? Unless somebody does something really dumb. So Jack's got really 2 places that are worth considering. 2 or 8. So, and Jill is not going to be beaten. So she's going to go to 9, right? No? Just making sure you're all awake. And so we're heading for a draw at this point. Now, if it was a smart transaction processor, and perhaps it should be, it should know this is a tie. Yeah. Instead, it's going to continue on to the bitter end. Jill, of course, is on a roll here, and so she's hoping that Jack is half asleep. And she's won, right? No. So again, this is a good example of the TP is saying, no, you can't play 2 in a row. Nice try. All right, so we'll give Jack the final honors. And so there, especially for the doubters, is a tie. Well, the end. Well, not quite the end, but we are on the home stretch now, I promise you. So, in conclusion, so another thing I could demonstrate, which I won't now in the interest of time, is one can scale the stateful sets, and add another validator. And all that will do is extend the size of the network. But the important thing is it will do that, and Sawtooth will sort everything out under the covers, so that new validator will come up or sync up. So if you then look at the logs for that one, you'll see a whole bunch of catch up. And then I'll tear this down later, and tear this down later, again, standard stuff. So, in conclusion, there's a roadshow, and this is both an advert for us as a company, but also more importantly for the Hyperledger community. If you haven't seen enough or heard enough, I'll be on a panel talking about something or other at the member summit. We'll be talking about some of the challenges of, what does it mean to go from proof of concept to production? What are the challenges? And that's not just about Sawtooth. That's bringing together a whole bunch of people talking about their experiences, of whom Monax is probably one of the most experienced, because Monax have been running Burrow for 4 years using Kubernetes. The Open Source Summit in Europe, which actually I can walk to from my current home in Edinburgh, will be there. Hyperledger is a little bit sparsely represented there, but there's a couple of talks. There's one by myself and Kevin, and then there's actually one of our meetups where we won't be talking. You'll be pleased to hear. And then the global forum in Basel in December. We're really looking forward to that. That was announced, or rather, the agenda was announced yesterday, I think.
Yes.
And it's really good. Lots of good stuff there. So I would say that's, and that's a chance for everybody. So the member summit is the internal private, everyone talking under, Chatham House or club rules, trying to sort of, make sure we're happy with the overall direction. But the global forum is really inviting the world to come and find out more about what the Hyperledger community is doing, and exchange of views and so on. So last word. B2B has a clear value proposition. Great. Well, I wouldn't put up something that says B2B has no idea what they're doing. But the last word, #2, breaking news, report out from PwC, or their global whatever blockchain survey 2018, which they brought out in the middle of the year. So this is a year so far, or rather it's a year since the last one. Blockchain is here, what's your next move? And there was a quote that made it not just into the report, but into a lot of the blurb and a lot of the press release, and it's this quote. And it's saying, as of now, US 29%, China 18%, Australia 7%. Obviously, it's most advanced, currently in developing blockchain projects. I would dispute Australia, frankly, but anyone from Australia here? I'll see you outside. However, it says, and this is really, really important, joking aside here, within 3 to 5 years, respondents believe China will have overtaken the US, shifting the early center of influence, or gravity, if you will, and activity from the US and Europe. Something to think about. And it's a lot of the reason why I'm here and intend to stick around. So with that thought, I hope this was interesting and useful. Sorry I went on a bit, but hopefully you got some value out of it. So, okay.
Are there any questions?
I'm like asking, can we go now?
Yes.
Just one question. Do you have any particular use cases where you would recommend using Sawtooth above anything else?
So I think, as I said earlier, I think it's been designed for scale, and so the repeatability and the sort of modularity is very powerful. So I think it has a lot of strengths in real-world production networks, by which I mean ones that will span multiple regions, not just at one or two orders of magnitude, but perhaps up to 100 or 1,000, kind of 3 or 4, which doesn't sound that large, but it is quite large for a gossip-based network. That, of course, is going to be one of the things that Kevin in particular is going to be talking about, is the networking considerations. Because if you imagine the cluster as a unit, and therefore it nicely fits with an organization or a department, something like that, then you can imagine people having control of their own clusters quite reasonably, use the same tools so that hopefully there's some coordination, but you wouldn't have cluster of N and a cluster of M where they're fully meshed. Because standard networking and wide area networking say that you nominate some pair or more, at least two or more, that represent sort of I don't want to say gateway because that's an old-fashioned term, but are essentially the ways in which you would mesh those together. So there's a lot more besides just Sawtooth. There's a lot of thought that has to go into the topology itself, beyond just, oh great, we can now run 10 clusters. Let's just have all 10 talk to all other 10. So now we've got wide area gossip across which we have to recognize, because networking has been around for a long time. There's a lot we can learn from our peers in the operations and networking space on how to do this. So whilst blockchain and things like Sawtooth and Fabric might be relatively new, there are some best practices that we need to follow. And in the case of AWS, you've got this sort of notion of a landing zone. So that's an example, not within the context of blockchain, but it's a well-defined way of a company connecting to the cloud. And so I expect to see best practices, whether it's from you or the other hyper cloud providers, providing us with some of that. So at the moment, if I go and use a template that's provided by AWS for Fabric or Ethereum, it's bringing up a sort of basic kind of development environment for people, but that's not what you want to run in the future. So I think its ability to scale, as long as you're intelligent about how you deploy it, is one of the attractive features, and its simplicity in that there's a small number of moving parts, as you could have seen. There was, really it's just the validators and the networking running at one level, and then whatever applications, whatever transaction process families you want to run above that. So I think that again is good design, good sort of architecture.
Okay, I got a bit of a question. I'm sorry if it's a little bit ignorant, but the scaling capability is being offered by Kubernetes, right? Not Sawtooth itself. I'm trying to figure out the dividing line between.
No, it's both. You can scale a Kubernetes cluster, sure.
Right.
You can add
more and more as much as you want.
Up to a point, yeah. But I should have maybe I should just there's scaling a cluster, and then there's actually scaling an application, a Kubernetes application. So Sawtooth is an application running and designed the way that we put the manifest together to play nice with Kubernetes. So you can scale the number of validators. The limiting factor is that the number of validators should not exceed the number of nodes in the cluster, because you do not want validators co-located on the same underlying infrastructure. And that's not because you couldn't make it work, it's because why would you do that in the kind of cloudy world? So there is a discussion that Kevin is having with some of our other developers about whether we actually, instead of using stateful sets for the validator, we use daemon sets, which means you always get a validator. Every time you essentially bring up a node in a Kubernetes cluster, you automatically get a validator. The challenge with that, I think that's reasonable, because in a sense, and this is another thing to bear in mind, we envisage, rightly or wrongly, that these clusters will be, generally speaking, dedicated to managing the blockchain network. Why? Because, again, cloud. Why would I run some other random application on the same cluster if I can run it on another cluster? Because we know from experience, and certainly my experience in the past, the complexity of adding more and more services onto the same, it doesn't matter how smart the clustering technology is, you're asking for trouble. And we're talking about production here, so I want this thing to be rock solid. So in that sense, daemon set is not a bad idea, but the caveat is we do not want every validator to run every known TP. So there's a lot of work to be done to make real that Venn diagram I talked about, where you're actually deciding or determining what TPs can run on what validators, and that's still work in progress for all of us. But yeah, I think you can show the two playing nice in that, you know, there's nothing wrong with scaling out the cluster. If that means you use the resource and get another validator, great. Then I don't have to demonstrate the scaling of a validator because it would just happen automatically, which I think is probably the right answer.
So would it only work with, I know you're using Docker images, so obviously it's going to work with Docker, but that doesn't scale as easily as Kubernetes. So is there anything else that this Sawtooth platform will work on other than Kubernetes at the moment?
Well, we've chosen to focus on Kubernetes because it's as portable as it gets.
Right.
And the early work that was done with Docker Compose by both Fabric and Sawtooth has severe limitations.
Right.
And is only really doing a kind of almost like a laptop environment. So it's kind of horrible. So I think, you know, I would say we're almost all connected these days, almost all the time. So I would tend to say, you know, establish an environment as your development environment, use that. If you really want to, you can obviously shut it down, but you're talking pence. You can set it so that actually you max prices, so it goes for spot instances. That's something else that Kevin's done. We turned that off for the demo because I'd like my instances to come up and not hang around waiting because the spot price happens to be higher than we were expecting. But so there are lots of other ways of kind of being judicious in your use. But you know, if you've ever done something on your laptop and then shut the laptop lid and then opened it, it's pretty disastrous normally.
Yeah.
Versus, you know, just getting kicked out of a session and then reconnecting. So I think you know, treat distributed systems seriously. Make sure the environments, even the development environments, even small environments, are a reasonable approximation to what's going to be happening in the real world. And generally speaking, that means multiple machines at least, or multiple, machines.
In the case of this, would it be multiple Kubernetes clusters?
At the moment, we're focusing on just getting things stable with one, but that will be the next iteration. Is what we want to do is put this out there for people to see and experiment with and give us feedback on. And you know, a couple of people have already asked whether they can have sort of access to that before we actually go completely public. We're fine with that on a sort of case-by-case basis because we want people to look at it as long as they're prepared to put in the time. And so yeah, so when we get into topologies for production, where, for example, you're doing a consortium, where it's logical that each member of that consortium has their own cluster, then you've got to start thinking more about, again, the networking considerations for doing that. And again, in the same way that I talked about scale not being something you add as a new feature, security is not something you bolt on after the fact. So, you know, this environment that I'm using is relatively locked down. So that means that we're going to, I should get a demo fairly shortly, but we want to use Prometheus as a way of just viewing the cluster. So we're going to have to do a little bit of setup to make sure that that is done for me, so I'm not having to faff around with certificates the whole time. But that's, I think, just, it's good practice. You know, make it hard to use, or hard to break into, I mean, not hard to use.
Cool. So, yeah, so I think, so thank you so much. So
yeah, thank
maybe
you,
we all
everybody.
have
And thanks for
another round
staying.
of applause for Duncan.
That was the short version.
Yeah. So, so we need to clean up this page, and I just want
Okay.
to maybe.